Good evening to everyone. My name is Shubham Mondal from Coachbar Government Engineering College. I am from Electrical Department, fourth semester. Today I talk about digital signal and digital circuits. Okay, first of all, my roll number is 349016230335. Okay, then uh, today we are talk about digital signal and digital circuits. Okay, then we move into the main points. Okay, firstly we talk about the introduction part of digital signals. Then look into the definition part. Digital signals are discrete type signals that represent data in binary form like 0 and 1. They are widely used in digital communication and computing system. Then this discrete nature of digital signals are unlike analog signals. Digital signals have distinct levels, making them more robust against noise and interference. Then processing and storage. Digital signals are easy to process, manipulate, and store, uh, enabling efficient data transmission in modern technology. Okay, digital signals application. Okay, they are used in computers, telecommunications, audio or video processing, and embedded systems, forming the backbone of digital electronics. Okay, then this is the digital electronics introduction part. Then we move into the next slide, is called characteristics of digital signals. Here is four points. Firstly, we move into look about the discrete values. Digital signals operate with discrete voltage levels, typically represent as binary 0 and 1, making them more reliable for data transmission and processing. Then the second point is less suitability to noise. Unlike analog signals, digital signals are less affected by external noise, ensuring better accuracy and signal integrity. The third point is efficient storage and transmission. Digital signals can be easily stored, compressed, and transmitted over long distance without significant loss of quality. Error detection and correction. Digital systems use error checking techniques such as parity checks and CRC to ensure accurate data transmission and minimize errors. Okay, this is the characteristics of digital signals. Then we move into the next slide, is called digital versus analog signals. First point is nature of signals. The analog signal part is analog signals are continuous and very smoothly over time, while the digital signals part is digital signals are discrete and use binary 0 and 1 to represent data. The next point, noise resistance. Here digital signal part is digital signals are less affected by noise and interference, ensuring more reliable data transmission. The analog signal part is analog signals are more prone to distortion. Then the third and last point is processing and storage. Here, the digital signal part is digital signals can be easily stored, compressed, and processed using computers. Whereas the analog signals part is analog signals require more complex and hardware for manipulation. Okay. Then we move into the next slide, is called introduction to digital circuits. Okay, here we firstly look into the definition part. Digital circuits process and manipulate binary data like 0 and 1 using logic gates and electronic components for forming the core of modern computing and communication systems. The digital circuits classified into combination two types, combination circuits, like output depends only on current input, and the sequential circuits output depends on current and past inputs. Then we move into the next point is reliability and accuracy. Digital circuits offer high accuracy, minimal signal discussion, and better noise resistance compared to analog circuits. The application part, digital circuits application part is used in microprocessor, embed systems, digital communication, automation, and consumer electronic like smartphones and computers. Okay, then we move into the next slide is called uh, types of digital circuits. Here is some points like combinational circuits. These circuits depends only on the current input to produce an output. Example include logic gates, adders, and multiplexers. The next point is sequential circuits. These circuits depend on both current input and previous states using memory elements like flip-flop. Examples include counters and shift registers. Then the synchronous versus asynchronous circuits. Synchronous circuits operate based on a clock signal, ensuring synchronous data flow, while circuits flow without a clock reacting instantly to input changes. These are the types of digital circuits. Then we move into the next slide is called basic logic gates. The definition. Logic gates are fundamental building blocks of digital circuits that perform basic logical operations using binary inputs like 0 and 1. The types of gates, the primary logic gates include AND, OR, and NOT, and the additional gates include NAND, NOR, and XOR. The combinational logic, these gates are used in various combinations to design arithmetic circuits, multiplexers, and memory units. The application of logic gates are essential in microprocessor, digital communication, embedded systems, and automation technologies. Then we move into the next slide is applications of digital circuits. Here are some points like computers and microprocessors. Digital circuits from the backbone of computers enabling data processing, storage, and execution. Of instructions. The next point is communication systems used in mobile phones, internet routers, and satellites. Embed systems found in smart devices, medical equipments, and automotive systems. The last point and the final point is signal processing and AI. Digital circuits power image processing, speech recognition, and artificial intelligence applications. These are yeah, applications of digital circuits. Then the advantages and disadvantages of digital circuits. Advantages: high accuracy and reliability. Digital circuits provide precise and consistent outputs. And the other advantage is easy data storage and processing. Digital data can be efficiently stored, retrieved, and processed using computers and microcontrollers. The disadvantages are high power consumption. Digital circuits require more energy, especially in high-speed processors and large systems. And the next disadvantage is complex circuitry. Designing digital circuits involves integrate logic gates and components, making them more complex compared to analog systems. These are the advantages and disadvantages of digital circuits. Then we move into the next topic, is conclusion and future trends in digital circuits and digital signals. The conclusion is digital signals and signals and also circuits have modern technology enabling efficient computing, communication, and automation. Their accuracy, reliability, and noise resistance make them essential for applications in electronics, AI, and embedded systems. The future trends like quantum computing, AI, and machine learning, and IoT and 5G. Okay, these are the some points to describe about digital circuits and digital signals. Okay, thank you.